Europe experiences totality for the first time since 1999. This week on Planetary Radio. I'm Sarah El-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. On August 12th, the moon's shadow will sweep across Iceland, Greenland, and Spain, bringing totality to millions of people who have never experienced it before. This week, astrophotographer Andrew McCarthy joins us to talk about what made his 2024 eclipse image so extraordinary, and what he's planning to do for this totally unique low-horizon total solar eclipse. Then, bioacoustics researcher and CEO of Haikubox, David Mann, shares the surprising results from the Eclipse Echoes project, which used a network of AI-powered bird monitors to listen in on how birds reacted to the 2024 total solar eclipse in North America. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit the subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. The day that this episode drops, August 12th, 2026, a total solar eclipse is sweeping across the northern hemisphere. Depending on when you're listening, totality is either just a few hours away or already behind us. Either way, this one is historic. The path of totality sweeps through Greenland, Iceland, northern Russia, the Atlantic Ocean, Spain, and a small corner of Portugal, marking the first total solar eclipse visible from Western Europe since 1999. Those lucky enough to be on that path of totality are going to get 2 minutes and 18 seconds of darkness as the sun's light is blocked by our moon. But the partial eclipse reaches much further than that. Parts of the northern United States from Alaska to North Carolina, most of Canada, much of Europe, and northwestern Africa will all experience a partial eclipse today. For many along the western part of the path, in mainland Europe and Africa, the sun will actually set while it's still in partial eclipse, giving those viewers a rare chance to see a sunset eclipse. If you've been listening to Planetary Radio since 2024, you may remember our eclipse coverage before the last total solar eclipse in the United States. In one episode called Eclipse Tips, a guide to safe observing and astrophotography, I invited astrophotographer Andrew McCarthy onto the show. He talked about how to photograph and safely observe the total solar eclipse. Andrew is an astrophotographer whose work has captured everything from the sun's surface to the far reaches of deep space. And he's been chasing eclipses since 2017, when a total solar eclipse crossing the United States first inspired him to pick up a camera and point it at the sky. Today he's back to tell us how that 2024 shot actually turned out, and to share what he's been doing since then, including an extraordinary collaboration with Artemis II's commander, Reed Wiseman. Hey, Andrew. Thanks for joining us again.
Oh, thank you so much for having me.
So the last time we talked, it was about the 2024 eclipse. I was headed out for Texas to our Eclipse-orama event, but I think the last time we spoke, you weren't even sure where you were going to be going yet to take that photo. So where did you end up?
I ended up in Missouri. The forecast in Texas, as you probably remember, was a little dicey.
Yep.
Some people saw it, some people didn't, and the people that did see it, still had clouds partially occluding the sun during the event. So I didn't want that. So I made the last minute call based on the last minute forecast changes to drive a couple states north to Missouri, where I ended up setting up where every forecast agreed there would be clear skies in this one little keyhole. And it ended up working out. I got the great shot, and it all worked out the way I wanted. It was just a lot of work. A lot of driving. Ended up, just driving just constantly. And then, I live in Arizona, so it's just all over the country basically for this thing.
Oh, it ended up being phenomenal. That photo is just startlingly beautiful.
Oh, thank you.
Can you tell us, what were some of the things that you ended up bringing out in that photo, and how many photos did you end up stacking to produce that result?
Well, since it's been a couple years and a million projects ago, I might not have the exact numbers, but I did have 5 cameras and telescopes going at once. And the idea was I wanted to show you everything that was happening in the sky, not just the sun, the moon, the corona, the prominences, but there was also a lot of stars that you couldn't even see visually, faint magnitude stars that I wanted to pull out. And I wanted to capture the full dynamic range that was present in the scene. So I only had a few minutes to do it, so I needed as many cameras as possible to gather as much light as possible. And by doing that, I was able to create a really, really high resolution image that has like really extreme dynamic range, like from the faintest stars to the brightest prominences. And that also has the benefit of more closely resembling what you can see visually. And what I wanted to capture more than anything was the emotion of witnessing an eclipse. So for that reason, as I was downloading these cameras onto my laptop, I was trying not to look at any other eclipse photos that I saw, because of course social media was immediately buzzing with them. I try not to have a preconceived notion of how an eclipse should look. I only went on what I had just seen through my binoculars and through my telescope visually, and how it made me feel. And I try to recreate that in the shot as much as I could through, balancing the light levels, balancing the color, and preserving some of the highlights and, bringing out some of the shadows in the shot. So the result I wanted to capture not just beyond what my eyes could see, but really go above and beyond in producing the emotion of witnessing the event. And I did about as good of a job as I think I could have done with what I had at the time. So I'm pretty happy with how it turned out.
You should be. It is absolutely beautiful. I know that last time you were saying you were going to try to capture that diamond ring effect. And we were speaking a little bit about the dangers to people's cameras when trying to produce that. Did you actually end up damaging any of your cameras while you were taking that photo?
Everything turned out pretty good. I've had a lot of cameras going, and they all had their own solar filters on them during the partial phase. And I had an alarm go off my phone 1 minute before the diamond ring would start. And once that alarm hit, I removed all the solar filters across all my cameras. And each camera had, various lenses or telescopes or whatever, and they were all stopped down to f8 or slower, which meant there was a little bit of a reduction in that light hitting the lens. Between that and how little of the sun was actually visible at the time, it wasn't enough to permanently damage any of my cameras. Or if it did damage them, it wasn't enough for me to notice. The biggest drawback of doing that was while the lenses were stopped down during the eclipse, they did get less light from the eclipse. And it also has the added benefit of exaggerating any dust specks that are on your lens or on your sensor, which show up in the final image, meaning I had to calibrate out those defects.
Yeah, this brings up a point that you said last time too, which is if you don't know what you're doing necessarily in a circumstance, maybe focus more on the moment than trying to mess with all your camera gear. Be there in the moment, and then if you fry out a camera, at least you knew what you're getting into.
Oh, yeah, absolutely. And honestly, that advice still stands today. A lot of people are traveling for this eclipse, and I would tell everybody, do not experience it through the back of your camera. I probably will be, because it's a very short totality. And because it's so short, I have very limited amount of time to get my shots centered and take the photo. And while I'm doing that, I'm probably not going to have very much time to look at it visually. I'm going to do my best though. I'm going to have binoculars around my neck that I can quickly pick up and look. And, so hopefully that'll be enough for me to experience the event. But otherwise, yeah, just, kind of get your settings dialed in beforehand. And that way you don't have to touch anything. You don't have to look at anything. You can just sit there and appreciate the spectacle, because it is just one of those things where it's you may only see one in your life, if that. And it's going to be a moment that you'll remember forever.
This is going to be a really interesting one, because this is the first total solar eclipse in that area in the age of social media. So, this is not only going to be a lot of people's first time seeing it, since it's been so many years. I want to say it was 1999 the last time it happened, but also it's going to be people's first time sharing it. And so people might try to capture it on camera just so they can share it, when in fact they should probably just be there and sit in the moment, because who knows the next time they're going to get that chance.
Yeah, I agree completely. You'd have to well, technically Spain has one again next year.
That's true. Yeah, if you live in Spain.
But yeah, if you're in Iceland, yeah, I still recommend just see it visually. You don't know what's going to happen with the weather next year, etc. One good thing about the timing of this one is that whole stretch from through the Mediterranean has historically very good weather in August. So I think we will see a lot of great photos. It's also going to be really low on the horizon. It makes it worse in some ways, but much better in others. Think about when you see the moon rising on the horizon and just how big it looks, because the horizon's contextualizing it for you. Without that context, being only a half degree wide in the sky, like the moon, the sun are very, very tiny. So I think this is going to look really big to people. Like when it's on the horizon, you're gonna be like, whoa, it's like just huge, and it just feels like it takes up this huge field of your view. Well, of course, the sun and the moon is still just half a degree wide, but because you're seeing it against that ocean or that landscape, you're going to see this context which allows your brain to kind of hyper focus on it, and you get like binocular vision. It's such a weird thing our brains do, and that's going to make it just much more visually impactful, assuming you have clear skies on the horizon. There is a downside, though. The downside is it is less sharp because you are seeing it through more atmosphere, and the fainter outer bits of the corona will probably be less perceptible.
So are people going to be able to get some kind of like combo if they combine photos around this time, since it's so close to sunset? Are we going to get some really weird kind of colorful images of people stacked that way?
Well, I think we're going to see some really interesting photos, just because I've never seen an eclipse this low on the horizon before. Of course, I've only seen a couple of them. They're both pretty high. So I'm not too sure what to expect. Light behaves basically the same, though. Like a sunset produces those colors not because of how bright the sun is or whatever, but because of how relay scattering splits the spectrum of light as it goes in at such a steep angle to our atmosphere. The atmosphere almost acts like a prism. As the sun gets lower, we shift more into seeing more of the red end of the spectrum. And that's going to happen even during totality. So I do think we're going to get some sunset effects. It's not going to be as bright of a sunset, so it might not be as prominent visually, but it should show up in photos. So my hope is that I'm capturing beautiful colors of that red light in addition to those blue hues of the corona. But I don't really know how it's going to turn out, just because I think the last one of these that we've seen that's this low on the horizon was kind of taken before the era of digital photography, when we had the dynamic range to really pull out a lot of what was happening in the shadows.
That's going to be so cool. Oh my gosh. And I want to know more about where you're going to be going and that next phase of your eclipse photography. But first, I wanted to acknowledge what I think is one of the coolest eclipse photos of this year, which came from the Artemis II mission. When you saw that for the first time, how did that make you feel?
My reflex was, wow, how does this reel? And then, being thankful that they went when they did, because this was only possible during certain launch windows. And, hoping that the crew just didn't spend too much time working and spent a little bit of time just sitting and appreciating. But of course, they are astronauts. They are very hardworking. So they were focused on capturing that moment and taking a lot of photos. But those photos that came back were just unbelievably mind-blowing. And what it does for me personally is it helps focus my energy towards the future of human spaceflight, because scenes like this won't become as rare. I think about how those experiences would transform you as a person. There's only 4 people on this earth that have experienced that. And getting more people to experience those profoundly beautiful moments, I think would just be very good for humanity. So it's, why I go down and I cover, the Starship missions, and go down to Florida and, cover crewed spaceflight missions, because I want more people to be aware of what's happening and hopefully get more help with more public support towards those things. So those photos that came back were very motivating for me to do my part and use my platform in getting more people to think big picture, long term for the future of human crewed spaceflight.
I understand you actually worked with the Artemis II crew on their photography. How did that happen?
Oh, yeah. So very interesting story here. So Reed reached out to me on social media about something else. He has one of my moon prints and wanted to comment on it, and it was very nice. So I had this avenue to communicate with Reed. And leading up to the mission, it dawned on me that we haven't had digital photography operated by a human beyond the moon ever. So not just since Apollo, because Apollo, they had limited film cameras, but just ever. And digital photography is what allows me to do very high dynamic range images of the moon, where you see not just the moon, but like the shadowed side of the moon, the stars behind the moon, the vivid colors that are present in the regolith, but not visible to your naked eye. And I thought, well, it's worth a shot asking Reed if he was interested in capturing the moon like this, because he has familiarity with my work. And he was just like immediately like, yeah, teach me, because, he's a humble dude. And even though he's been through like a million digital photography courses for moon photography, he still saw an opportunity to learn. And I guess that's what makes him an astronaut.
Right.
So, we basically just went back and forth, came up with a plan for how to capture the moment, because it's very limited windows because they're flying by so fast, and that was incorporated into the official plan that the actual NASA media team in charge of the Artemis photos would put together. Basically, he went up and was shooting these bracketed shots in specific bursts and got enough photos for me to stack together and bring out the colors of the moon in a way that we'd never seen before on the dark side, or I should say the unlit, or the far side, because it is lit. But that's a little bit of a misnomer as well, because most of the far side was actually in shadow when they went behind the moon, which was unfortunate, but of course made for a very beautiful crescent Earthrise photo, which I loved. But the downside of that is we weren't able to see all of those colors on the rest of it. But we were able to see some incredible definition in Mare Orientale, which is that giant impact crater. It's like, I forget how big it is. It's like 1,000 miles wide or something. And that area was of particular interest to me. And because of the phase, we actually got some really nice crater relief in it. So those photos that turned out, even though they are showing technically the moon from the side, showed us details that we've never seen before. And in fact, as I was processing that data, I may have been the first human to ever see them, which is a really weird feeling, because even they weren't visible in the raw photos they sent over to me, only in the stacked photo once those colors were brought out. Can't believe it happened.
That's so amazing. I mean, I remember thinking when they had to delay the launch of that mission that it was such a bummer that we weren't going to get more lighting on the far side of the moon. But then by circumstance, it meant we got to get that eclipse photo. So in the end, it all came together. But I'm really glad that you got to take the time to do that. And I would love to see future Artemis crews get to learn more from you and other photographers, because I think there's something really special about trying to bring out the emotion of the thing that you've been speaking about, like not just the technicality of the imagery, but there's so much that goes into astrophotography.
Yeah, I agree. It would be nice to actually spend some quality time out there to work through some of these challenges that you face with photography. Astrophotography, it's taken a long time to get to where it is, because it's not like point and shoot landscape photography. You're capturing very, very old photons, and thanks to the inverse square law of light, they are very faint and very dispersed by the time they reach your camera. And because of that, there's a lot of techniques that have to be developed. A lot of times you're shooting an object that is so dim that it's not even above the noise floor of your camera. Like literally the black body radiation that strikes your sensor is the strongest signal compared to what you're actually trying to capture. And doing that from orbit presents even more challenges. You're dealing with reflections from the inside of the spacecraft, and lights that can't be turned off inside the spacecraft that are interfering with this. You're dealing with the distortion through that pressure window. The multi-layered glass that has to keep the astronauts alive. You can't mess with that. So you have to figure out a way to work through it. And then, of course, you have the challenges of just floating and not having a stationary tripod to set your camera on while you're shooting. And you have the stars that are moving faster. They're moving at different rates depending on what your spacecraft is doing. If it's changing angles relative to the moon, then the stars are moving at a weird speed. And the 500 rule no longer applies. The 500 rule being how long you can expose for with the rotation of Earth blurring your photos. So there's all these challenges, and some of them have been addressed from the space station. Don Pettit's very resourceful and has come up with a few different trackers, for example, that compensates for the spacecraft's motion, and has done some incredible astrophotography from low Earth orbit. But as spaceflight expands and we send more missions out beyond low Earth orbit, it's going to present even more challenges. And it'd be really great to be able to get some incredible photos of like Earth against the zodiacal light, or even just deep space objects unfiltered through Earth's atmosphere in a wide field of view that we've never seen, because space telescopes generally have a very narrow field of view. So all of these are challenges that we should overcome in the future of astrophotography in space.
Thankfully, with this upcoming eclipse, you don't have to deal with any of those challenges. You just get to take it from here on Earth. There's enough challenges there as it is. So what is your plan for coming up in August on the 12th?
So my plan is always going to be depending on the weather. So I actually had a primary location that I had picked out that just yesterday I ruled out based on what's going to be happening on the island with officials closing down certain viewing places. And so I was going to shoot it from Majorca. Now that I know I'm not going there, I don't mind sharing that. I don't like saying exactly where I'll be, because then people will show up and be like, hey, can I talk to you while you're shooting this really important photo, and I get too distracted. But I was going to shoot it from Majorca, and I always subscribe to Google Alerts if I have a big shoot coming up, filtering for keywords surrounding that location. And I got an alert that officials are closing down both my primary, secondary, and tertiary locations on that island that I was planning on shooting at, because they're worried about overcrowding, fire safety, evacuation safety, a lot of things that are, of course, very important. So I'm not going to, speak ill of the regulators that stepped in and said, no, we've got to keep people safe. But it meant they are funneling 300,000 people into one beach on the west side of the island. Because of the nature of the terrain there and the location of the eclipse, there's really only one spot to view it, even though the path of totality covers the whole island. And I'm going to have a lot of equipment. Setting up on a crowded beach full of people is going to be very, very hard for me to get a shot. One, seeing over that many heads, that alone is a problem. And also, frankly, like I was saying earlier, I get distracted. If people are out constantly asking me questions about my gear, which they do, by the way, I will unfortunately forget things. So it's frustrating, because I actually really love talking to people. When people ask me about space, just like you're doing, I won't shut up about it for hours. But in the seconds leading up to a total solar eclipse, I gotta be locked in. So for that reason, I ruled out Majorca, and now I'm evaluating other locations, which I'm not sure which will work out. It will depend on weather. It will depend on other logistics, such as, am I even allowed to shoot there? Hopefully I'll have some really cool photos, but I'm still very much in somewhat of a limbo. I'm not really sure exactly where I'll end up.
But for people who aren't going to be using, 5 cameras and a telescope and all those other things, what's a good beginning setup for someone who maybe has a DSLR or something like that, but, hasn't attempted something like eclipse photography before?
Well, as mentioned, priority should always be experiencing it visually. That said, if you're dead set on getting a photo and you feel like you'll have massive regret if you don't, what I'd recommend doing, if you do have a DSLR, use a nice long focal length. I use something like an f8 aperture. The reason for that is just basically it's a nice middle ground. It lets enough light in while also stopping down the lens enough to keep things sharp. And you can use autofocus, but I would actually recommend just focusing on something that's infinitely far away first. There's actually depth of field calculators that you can use to figure out if something's far enough away to technically count as infinity to the lens. For example, you can focus on the horizon, you can focus on a distant cloud, not the closer clouds, like the distance clouds, distant mountains, that type of thing. And once you've done that, switch to manual focus, because the last thing you want your lens to do is to try to focus on something it's trying to shoot it and you only have a minute. So, you really don't want to mess with the focus during the shot. And then, of course, the actual shot itself. Now, there's a lot of dynamic range in the eclipse, so it's hard to know what to do. You're like, well, should I just use the automatic settings? Well, automatic settings are going to try to balance your histogram. And if your histogram is balanced, it will actually be overexposing right around the lunar limb, where all that bright detail's happening. Prominences and the brighter parts of the corona are right there, and they will be blown out and you will lose detail. if you use automatic settings. But if you shoot too low, then you're no longer going to get the outer bits of the corona. You're only going to get the inner bits, are still really cool. Like that's where you see the pink prominences flying off the sun. Like those are the coolest parts of the 2024 eclipse. I can't wait to capture those again. I hope we get a big one. How do you get the best of both worlds? And the answer, of course, is HDR photography. Like I mentioned earlier, HDR photography is when you capture different brackets of shots. So you get short exposures where you capture those really, really, really bright bits. And then you also do longer exposures that allow you to capture those faint outer bits and maybe some stars if there's enough stars visible. And then you can end up with something that more closely resembles what the human eye can see once you've combined all of this data together. Now, combining the shots together are a challenge that not everybody's necessarily up to. But by bracketing your shots, you will allow yourself the opportunity to kind of go through and pick which style you like best. Really hard to know how things are going to turn out if you don't have the experience going into it. But then you might be like, oh, I have a photo of the very, very bright corona, and it shows up really great in this photo. But then also you can look at some of your darker exposed shots and zoom in on the prominences around the sun and say, wow, now check this out. I also saw this during the eclipse. So getting that variety of shot, even if you don't know anything about HDR photography, I think is really helpful in just capturing as much of the scene as you can. And it's actually pretty easy to set up on your camera. There's, you just go through and set I want 5 or 7 bracketed shots, and you can set up your little spread on the automatic exposure bracketing setting. But yeah, you can look it up for your camera, basically how to bracket the shots for the upcoming eclipse. And then use an intervalometer. Intervalometers are really important to not shake your camera while you're shooting. Have it on stable ground, stable tripod, and set it up so that it'll fire these shots automatically. So you don't have to sit there and adjust settings, look through the eyepiece. You can just watch the eclipse and know your camera's doing the work for you, and then you can review those shots later. And then even if your photos don't turn out, you don't regret it because you experienced the event, and that's the most important thing.
What technology would you recommend people use for actually stacking the photo once they get it?
For a beginner, I would say probably the easiest thing to do is if you have Photoshop, just throw all your photos in Photoshop, manually align them. You drag them around until they're more or less perfectly aligned. And then you can do a very simple median blend of all the photos so that you're combining the brighter shots with the dimmer shots. And once you've done that, you can just edit the photo from there. If you know anything about just editing photos, there's a million ways to do this, and there's not necessarily one distinct right answer. I would actually encourage people to try to just tinker with the shots and not worry about following some tutorial. There are tutorials out there for editing these, but if you do it yourself without trying to follow some kind of pattern, you're going to come up with something that's very unique to you. And these photos are somewhat of an artistic expression too. So getting something that's very unique is how we discover new things. It's how we inspire people, by coming up with something that's new. And that's what I always try to do with these shots is I'll put it together, and instead of kind of following some method that's tried and true, I try to make my own way, come up with my own ways of blending the HDR data together. And once I've done that, I can usually come up with a shot that stands out above some of my peers that are maybe doing it the technically most correct way, but that's not necessarily what I want to do. What I want to do is create a piece that evokes emotion. And I would encourage other people to attempt to do the same.
It's fantastic advice. And I hope that it produces all kinds of fun images, and that for the first time ever, people get to share these things online from a whole part of the world that's never had the opportunity to do that with social media. So this is going to be really exciting for everybody involved, and I cannot wait to see your photo. I'm just seriously, so much luck to you and everybody who's going to be taking these photos.
Thank you. I'm really looking forward to it. Hopefully I don't let you down.
We'll be right back after this short break.
Hi, I'm Kirby Runyon, planetary geologist at the Planetary Science Institute and founder of Planetary Experience Consulting. Think of your favorite photograph from the moon or Mars. Have you ever wanted to read the stories recorded in those rocks? You can learn how. This October, I'm co-leading a 3-day expedition to some of New Mexico's finest planetary geology analog sites, and I'd love for you to join me. From October 15th through 19th, we'll explore tube-fed lava flows at Carrizozo, soak in the volcanic desolation of Kilbourne Hole volcanic crater, and stand at sunset over the sublime White Sands National Park. These are some of the same landscapes where Apollo and Artemis astronauts have trained. We'll also visit Spaceport America, the New Mexico Museum of Space History, and the Las Cruces Challenger Learning Center. Space is limited to just 20 people, and for every person who registers, the Planetary Society will receive a donation. Head to planetary.org/travel to learn more and save your spot. I hope to see you there.
A total solar eclipse is without a doubt one of the most awe-inspiring events in nature. People travel for miles to stand in that path of totality, and when that moment comes, there are tears, cheering, and sometimes stunned silence. But what about the animals? There's a long history of anecdotal reports that birds go quiet during totality. Scientists have been trying to pin down what's actually going on, and the 2024 eclipse gave them a rare chance to find out. Our next guest, Dr. David Mann, is the founder and CEO of Haikubox and Loggerhead Instruments. He led a team that used a network of hundreds of AI-powered backyard microphones to listen in on birds across North America during that April 8th, 2024 total solar eclipse. It passed through Mexico, up through the United States, and into Canada. Their findings, published in scientific reports, tell a much more complicated story than anyone expected. Hey, David, thanks for joining me.
Thanks for having me.
So first, I want to say how excited my colleagues at the Planetary Society are to talk about both birds and eclipses. We have a lot of avid birders on the team.
That's great.
It's funny because, just the other day, I was talking with a coworker about how much my mother loves birds. She sits out in her yard, she listens to the birds, and she tries to identify them. And they all told me that I should give her the Merlin bird app, which I understand has this similar connection to your Haikubox technology through Cornell. Have you ever used the app before?
Yes. We use Merlin all the time when we're outside trying to figure out what a bird is. It's free. Everyone should get it. Everyone should use it. It's wonderful. Yeah, so it's similar to what we do. So I can briefly explain what Haikubox is. So if you use Merlin, Haikubox is like a Merlin that's running all the time at your home. And so it's listening for birds. And when it hears one, it runs it through neural networks to identify what bird it is. And then it's all kind of recorded, in a cloud system. So you can sit on your phone whenever you can get a notification, oh, we heard a screech owl, and then you can go run out and find it. So people have these mostly in the United States, but also in Europe and scattered places. And so it's running continuously. So we have these great records of bird activity around the world.
That's so cool. I mean, it's a great way to track bird migrations or just figure out what's happening outside your door. In my area, we mostly have those red-crowned Amazon parrots. They're everywhere in Pasadena.
Nice. Yeah, in Florida, we have these Nande parakeets that are flying around. It's you're not from here, but
I know, right? It's wild hearing them all go over. But, out in the wild, there are so many different animals to identify, which is why I'm glad we're doing this kind of science, both just for bird identification, but also for this kind of eclipse science, which I know people have tried in the past to try to figure out how animals react to eclipses. But this is a very different take on doing that kind of experiment. How did the idea for Haikubox come about?
Haikubox actually came about when I was talking with Holger Klink, who's director of the Center for Conservation Bioacoustics at the Cornell Lab of Ornithology. And so he and I both have actually an oceanography background. And so we've done a lot of work on marine bioacoustics like fish and dolphin whale sounds. My company has been making underwater acoustic recorders for quite a long time. I was talking to him about, I was like, we want to do something that's more a consumer bioacoustics product. And he said, hey, we have this new thing. I have this grad student in Germany, Stefan Kahl, who developed BirdNet. And what BirdNet was, it was the first convolutional neural network that was really good at doing birdsong ID. And so we hooked that up in a Raspberry Pi, and I stuck it in my backyard in Florida. And I was like, oh, this is cool. And then we had funding from National Science Foundation small business program for a few years around 2020. Originally, we were going to do oceanography stuff, and then it was sort of like we were all at home in the pandemic. And so that actually, the pandemic was a big sort of driver for us to kind of focus on Haikubox and get that going.
How does Haikubox work, and what kind of science are you trying to do with it?
So Haikubox is basically, it's got a microphone on it, and we're digitizing the recordings. And we've been through a few iterations of kind of what the hardware is on the device. So, we call it the Edge device. And so in the early days, we were running these Raspberry Pi compute modules. And then we had a supply chain crunch in like 2021, and we couldn't get them for a year and a half, which was like, okay, that's not good for a business. So we ended up switching over to just a much lower power, computationally and power microcontroller. And so now we run a small net on device that can do like 100 species ID. So the bird net, just FYI, like at the time was like 1,000 species, which it covers pretty much North America and Europe. And now they're up to, the latest version is like 11,000.
Wow.
Species. Yeah, it's really incredible. So we've now switched kind of to this hybrid thing where we were doing detection of common species and birds, but then there'd be a bird that's like not common and it's not in our local edge net. And so we basically send the audio clips to a cloud system, and then that is running much larger neural nets over the audio that comes in. And so that's how it works, right? It's sort of like a somewhat smart microphone in the device, and then there's a lot of processing on cloud servers to do the detections and classifications.
And what kind of science can you do with that much bird noise data?
I wish we could do more. Actually, so anyone listening who's scientists or want to be, we will make the data available. So, we share the detections with Cornell, but there's like so much that can be done. So we have billions and billions of detections now. The Eclipse study was sort of perfect that we did because, like, one, we knew it was coming, so we could get ready and make sure, like, are we collecting everything we want to collect from this? Mm-hmm. And it was, it's an event that has, a beginning and sort of end. And so you can isolate it. So, but like other things that we want to look at, right? Like the effects for right now, there's wildfires in Canada with smoke that's coming down into the US, kind of like Michigan through the East Coast of the US. So it'd be like very doable to look at, like, how do the birds react to that? Right? Just very simple question. And so I'll like just quick, like flip around and go like, where's the worst smoke? And like, are the birds still calling? And I'm like, oh yeah, there's still birds calling there. It's like not obvious. And so that stuff, it just gets a lot more complicated. So we have a few thousand of them running now. And when you have that scale, it doesn't matter that, some birds are calling some days and not other days. You can kind of average all of that out. So those sorts of things are things we can look at. We can also look at, like, as you mentioned, migration. Like the first ones we set up in Florida are still running. So we have over 5 years of data. It is open if people want access to it. So there's a lot you can do and lots of questions you can ask. Like what we're doing now is actually trying to develop tools to make it easier to actually work with the large data set and integrate other data sets like weather.
And I want to ask this next question just to put some minds at ease. I know there's been a lot of public backlash to these kind of AI-enabled listening devices, like passive recording devices over the years. How do you handle data privacy with Haikubox? And is the data strictly used for scientific purposes?
Yeah, so we don't sell the data, and we will never sell the data. So for privacy, the main thing is like human speech. So we basically have, on the Edge device, we have a net that detects human speech and sounds. And so we try not to upload that ever. We sort of need to know that it's happening. So for example, during the Eclipse study, we analyze the data around the eclipse. The one thing that's weird that happens during eclipse are hundreds of thousands of people go out in the middle of the day and are like in awe and like screaming or shooting off fireworks or doing all sorts of things. And so that will affect bird behavior just as much as the eclipse will. And so actually, to some extent more. And so our system, right, since we're rejecting speech, it'll suddenly look like there's no birds calling, but what's really happening is we're just rejecting all of this human noise. Yeah, so we had to go sort that out, and only half of our sites were quiet, human one.
Yeah, no, I was thinking about that actually during our Eclipse-orama festival that we threw in Texas during the last big event in the United States, because we were trying to add to the citizen science on this by recording the sounds. But even on my own recording, all I got were humans screaming at the sky, basically. And I'm sure that that's been really tricky for previous groups that have been trying to do this science around eclipses. How do you separate that out? So in your case, you just basically got rid of all the tracks that had human noises in them?
Yeah, we basically, I think it was an hour before and an hour after. If we detected any human, we just excluded the site.
Oh, wow. But I mean,
that's why we got rid of half of them. And even some, we get firework, we have a fireworks detector. That was going off. And I'm no, if you're shooting off fireworks, we're not going to look at bird call rates.
But so in the end, when you finally ended up going through the data without any human interference, what did it actually show about what the birds were doing during the eclipse?
Yes. So since we knew it was coming, we spent a lot of time trying to get ready so we could go, we would have an answer instantaneously, which we did, but that didn't have the human exclusion part in it. And so it was just it got really quiet during totality, was sort of our initial reaction. And then we went back and just looked in a lot more detail at it. And we're okay, well, we have to throw away half the sites or exclude them from the analysis because there's people doing things. And then there's no one blanket thing birds get quiet during the eclipse. So it was a highly variable response. There was clearly a response. In some cases, it was the birds really got quiet. So in our paper, I'm just kind of looking at it now. It's this one site, Pine Siskins, they started increasing their calling right before totality, then it drops to almost zero, and then it picks right back up again. But I go to a different site and I can see American robins just started calling 6 minutes before total obscuration. They just started calling a ton, and then they got quiet. And then 6 minutes after the total obscuration, it's northern cardinals started calling at this site. And I can go to a different site where there's American robins, and they don't do the same thing. Mm-hmm. So it was highly site dependent, highly species specific. And if you looked at just one of them, you can tell a great story. But when you look at all of them taken together, you're I don't know if I could predict what even a species will do at a site during eclipse. I mean, it's a weird thing, right? If you think of yourself as a bird, right? So a lot of birds have a thing called a dawn chorus, especially in the spring and even now. So right now I'm up in Massachusetts, and there are cardinals calling at 4:30 a.m. and oh my gosh. So some species will have this dawn chorus where they just call a lot in the morning, and then they kind of quiet down a couple hours or even an hour after sunrise. And then some have a dusk chorus where they'll call a lot too, but it's not nearly as strong as the dawn chorus. So if you're a bird, right, and it's, the eclipse is going to be passing you kind of midday, it's going to seem like dusk is coming and nightfall is coming. But then as soon as it starts going away, it's sort of another dawn. And then they have a circadian rhythm that other things in their bodies are controlling that are triggering whether they're going to call or not. And then the other thing is the eclipse in the US, right, was April 8th, the spring. And it went from Texas all the way through Maine, Canada. So that's right when a lot of birds are migrating. So there's early migrants and later migrants. And so there's just different communities of birds in different stages of migration, or ones that don't migrate, they're getting ready to breed. So a lot of those things are all overlaying on this weird thing that's happening. And then there's other stuff that happens too, the winds change, it gets noticeably cooler. right? So it just feels like a storm's coming. And so your reaction to that might be like, oh, let's hunker down. There's a lot of them that peaked like 3 or 6 minutes after total obscuration, and pretty commonly. And so I don't know if that is sort of a dawn chorusy thing. I don't think so. It might be a dusk chorus thing. But also that's like when the weather effects are not immediate. So a lot of them I think happen after totality, or after peak totality. And so that they may be reacting to that as well.
Mm-hmm. Yeah, that was really surprising to me during my first total solar eclipse. Like the temperature dropped, and then immediately after the eclipse left, we got these really intense winds that literally almost blew my tent away. So trying to figure out the difference between what things the birds are responding to is really complicated.
Yeah. So we looked at, across sites, we looked at for effects of temperature, wind speed, cloud cover, and kind of whether the site was northerly or southerly in the US. And we didn't really see any consistent relationship to change in vocalization rates with any of those other things.
But it did appear that, at least during totality, there was a significant drop off, even if some birds on average. Yeah. So it's like, even if all the different bird species are reacting differently and every circumstance and every location is different, on the whole, we can say that they did in some way quiet down during that time.
Yes, on average. And it had to be in a place with like more than 99 point something % obscuration too. So like so I was in like Massachusetts, and so we didn't get total obscuration. And then one of our our employee that does the AI stuff, he actually traveled to Indiana. And so he was like texting us during it. He was like, I was like, it's okay here.
But from like a bird's perspective, what's the difference between 99% totality and 95% totality?
The amount of light change is very drastically different. Like even 99% covering the sun, it's still pretty bright. It's it's like a cloudy day, like a bad storm cloudy day versus night. And so I have never experienced it, but it's like for you, right? Is it like night has fallen extremely rapidly?
Exactly. Everything goes so dark, and you can even see the shadow oncoming. I don't even know how to describe it, but it is. It's very dark. All the stars and planets come out in the middle of the day. It's a trip.
Yeah.
God, it's going to be so confusing for the birds.
What's going on?
Yeah. And the dip in vocalization wasn't even centered during peak darkness. It was maybe, it started at totality, but then extended for a while afterwards, maybe about 12 or so minutes, if I'm reading the paper right. So what do you make of that asymmetry?
I had a sense that it was related to it getting colder, which, it gets dark faster than it gets colder. And so that's the only thing I was, think it could be. Or it's like really sinking in like, oh, something's going on.
Right. Yeah, I mean, that's got to be so wild. And unfortunately, we don't have another total solar eclipse in the United States until like 2045.
Yeah, I just looked at the path on your website for the upcoming one, and like we only have like 3 in the path in Spain. Like we have one in Iceland, but it's on the north coast, and yeah.
For people who live in Europe, I mean, clearly the one coming up, you don't have a lot of Haikuboxes, but we have several coming up in the next few years. So what would you recommend that people in Europe and the Middle East do in preparation for something like this if they want to contribute to bird science during that time?
I mean, if they can make any recording without people that is sustained, like an hour-long recording, that would be useful to have. And you can record with anything. You can record with your phone. You can, whatever.
Yeah. Where would they want to submit it in order to be helpful?
So Cornell will take submissions of bird audio clips. And then there's a website called Xenocanto, Xeno-Canto, that has a lot of just user-contributed animal recordings, which is great. And just kind of going back to the neural nets that are doing the ID, they are all built off of people making known recordings of known species. And so you basically want thousands of recordings from lots of different places of each species to be able to train the net to do the ID. So that's like where a lot of the value is coming from, or sites like those. Mm-hmm. The things about Haikubox are, most of our data are from 30 species or less. So the common species, which are like the crows, the cardinals, the jays, chickadees and titmice and things like that, a lot of them are very broadly distributed. So you can find like American robins in a lot of different places. When we were first starting off with Haikubox, a lot of avid birders like really want to find the rare bird, right? And I was like, we're going to have to find a way to make blue jays interesting. But they are. So some of the birds that are the most challenging for us in terms of like false detections are things like blue jays, because they'll imitate hawks to try to scare other birds away. Like, oh, I'm going to imitate a hawk and like affect like my neighbor's behavior. They can just make all sorts of crazy sounds.
Well, I love knowing that even beyond humanity, the animal world is interacting with this completely strange, very Earth-centered phenomenon. I mean, the chance at all that the angular size of the sun and the moon would be the same size on our sky is so rare, let alone finding a world with life that has that circumstance. Thank you so much for joining us to talk about this.
Thank you so much.
For links to all of the amazing images and research that we talked about in this episode, along with a lot of Eclipse resources, you can go to the website for this episode of Planetary Radio at planetary.org/radio. So, birds have complicated feelings about total solar eclipses. But what about planetary scientists? Now it's time for What's Up with our chief scientist, Dr. Bruce Betts. Hey, Bruce.
Hello, Sarah.
Man, I'm just a little jealous of everybody that's over in Europe right now. They actually get to see this eclipse. Meanwhile, in California.
You can always root for it to be cloudy.
Nah, they deserve it. It's been so long since they had a total solar eclipse over there, like 1999. They deserve it. I hope it's beautiful.
Yeah, well, any given spot doesn't get a total solar eclipse very often. It's a little path. But yes, of course, we wish happiness and beauty and joy. Total solar eclipses are super cool.
I mean, I know I've said this on the show before, but like I think about this a lot. Like, how lucky and weird is it that we live on a planet where the angular size of our moon and our star on the sky are exactly the same, and they align such that you can see a total solar eclipse. Like, yeah, there's all this sci-fi about, aliens going through the universe looking for water or like some kind of thing. If I were some kind of extraterrestrial, I would travel the universe looking for total solar eclipses. That's how weird it is.
That's how weird you are.
Yeah, that is also true. What's the coolest total solar eclipse you've ever seen?
I've only seen two, which is still pretty cool. And the coolest was I saw 2017 and 2024, the two that crossed portions of the U.S. And 2017, I'd have to rate higher in terms of the eclipse because it was a clear blue sky, pretty much all the way around. So it was just spectacular and impressive, and with the darkening. But if you look off at the horizon, you can see parts that are still lit up, and just the experience to be able to see the corona. Of course, they always say, don't use cameras, focus on the event yourself. But part of my joy is in trying to get pictures. And so I went ahead and did that and got pictures, and that was cool. And then the other total solar eclipse was our eclipse event that we had in 2024 in Texas. And that was super cool because it was cloudy, but the clouds cleared just enough to see it for the totality. So, and of course, having hundreds of people being excited at the same time.
That was super cool. And I was so grateful that the clouds parted just for that moment of totality. The entire day, I was just like, oh, is this we've got 800 people in a field out here for an eclipse festival, and then it's like raining on your star party, right? No, but it actually, just for that moment, the clouds parted, we got to see it. It was magical.
Well, I look forward to hearing how the experience goes with the European eclipse and Greenland, and we'll see what happened. And a lot of partial eclipse all over Europe and Africa and the Atlantic if you just happen to be hanging out there.
Right.
All right, let's move on to
Random space fact. Rewind.
What you got?
I got comets. And this is one of those things that a lot of us know, but if you don't know it, it's pretty weird. Comet tails always point away from the sun, at least basically. This is true even when they're going away from the sun. So the tail leads as they're headed away from the sun because it's an effect of the solar light and the solar wind, depending on which tail you're talking about. And you don't have the atmosphere that we have on Earth, which makes you think all of that. Tails are always behind the thing. It's just weird. It's weird. You look at it, your brain tends to go, it's going that way, but it's really can be going the other way. There you go. That's your random space fact.
Super weird. And also interesting, I mean, for whoever is listening to this episode on the day that it comes out, the Earth will currently be plowing through the trail of debris left by Comet Swift-Tuttle.
Swift-Tuttle.
Swift-Tuttle for the Perseid meteor shower. I learned that from you and got it right at a trivia contest at
Yes.
Astronomy on Tap the other night. So I credit that one to you, Bruce.
All right. Well, I guess that makes sense. It would be at an astronomy gathering that you would get that as a trivia question.
Always.
All right, everybody, go out there, look up the night sky and think about the joy you see when you look up whatever you see. It's a bird. It's a plane. It's a total solar eclipse. Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in our Planetary Radio space in our online member community. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members around the world. You can join us as we continue to marvel at our amazing place in this universe at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, happy eclipse viewing and ad astra.